All right, so we are doing exponential functions, and just to get you guys thinking a little bit about it before we get started is, what is an exponential function? Okay, it's something raised to an exponential power. So a very typical one, y equals 2 to the x. Do you guys know what that graph looks like? Yeah, it's an exponential function looking something like this. Okay, important things to note is that the domain for something like this is going to be domain goes forever this way, forever this. So your domain is going to be all your real numbers, or you can say from negative infinity to positive infinity. Your range, if you look at this actually has an asymptote, and an asymptote is a line that your graph approaches but never ever ever will cross. So it has an asymptote at y equals 0. And so your range becomes from 0 all the way up until infinity. So your range is from 0 to infinity. And that's a soft bracket because it doesn't include 0. Okay, and then they're going to do different things with this one. They're going to go ahead, oh, what does a negative 2 to the x look like? What does that do to your graph? Okay, what does a negative and a negative right there do to your graph? So let's play around with that. Let's see if this works. Okay, so for this one, let me put it on projector mode. There, oh, it's a little bit better. Okay, so for this, well, we know y equals 2 to the x. And again, if we did our table of values right there, we could see it crossing at, we'll talk about how to graph it later, but just to get the idea of what that graph looks like. All right. Oops, did I undo that? Okay. All right, so don't write any of this down. Oops. Okay, so here we have y equals 2 to the x. So if we put a negative in front of this, what do you guys think that negative is going to do to your graph? Correct. It's going to reflect it across the x-axis. Instead of opening up, it's opening down. Okay? All right, let's see. Now, go back to our original graph. If we take this graph and we add a negative in front of the x, what do you guys think that's going to do to your graph? Okay, well, if this one reflected it across the x-axis, then the negative right here with the x reflects it across the y-axis. So it takes this one and it mirrors it. All right, last one says, wait, if this is your original function, what does a negative and a negative do? Well, we know the negative reflects it down, right? So, and then this negative will reflect it the other way. So do you guys know what that looks like? Okay. All right. So that's what the negatives can do to your graph. Usually we're working with this graph right here, and that is exponential growth because your base is a number greater than 1. If I were to put 7 here, same thing, it's going to go up a lot faster. If I were to put 8, if I were to put 21, it's just going to go steeper and steeper. Okay, so this is exponential growth. Now, to get exponential decay, what kind of a number would you need there? A number less than 1. So a number less than 1 is going to give you exponential decay. All right, so here's your exponential decay. Oops, let me get rid of that. Exponential decay. What is the negative going to do to your graph? Okay, the negative here, same thing. It's going to make it open down. All right, so we have that. What is a negative x going to do to your graph? It's going to reflect it across the y-axis. There you go. So then the last one is, what will a negative do to your graph? Okay, it's going to reflect it across the, open down first, so across the x-axis, and then it's going to reflect it across the y-axis. So can you tell what that looks like? All right, there you go. Okay, so notice that this is exponential decay because it's going down. But if I were to put that negative with the x, oh, okay, now my graph is all of a sudden exponential growth. And same with this other one. And this one, we know this is exponential growth because of your base. But if we put that negative with the x, all of a sudden it made it exponential decay. All right, so go ahead and write this down. This will be your notes. And you can make these graphs kind of small because we'll make nicer graphs in a minute. This is just to get the idea going. So we know we have exponential growth. This one. Looks like this. And again, what does that negative do to your graph? It will reflect it across the x-axis. It makes it open down. And it's a good idea to include the asymptotes. So the negative here reflects across your x-axis. To the negative x. What does a negative exponent do? Well, that's going to reflect it across the y-axis. So if we take this and reflect it across the y-axis, it also now makes it exponential decay. Let's add that. So in this case, this graph is exponential growth. Neither. This one, that negative exponent is going to make it exponential decay. Okay, decay going down. All right, the last one, y equals a negative 2 to the negative x. So this is going to reflect it across the x-axis, and then it's going to reflect it across the y-axis. So what does that look like? Okay, we're going to do the same thing, but we're going to do this for exponential decay. So y equals 1/2 to the x. If you're using a calculator, you would actually put this in parentheses. Or maybe I should just to make sure. Exponential decay is going to look something like this. And again, these are just small graphs. We'll actually make good graphs in a minute. So this is decay. Decay because your base is less than 1. If we add a negative to that, so y equals negative 1/2 to the x, what's that going to look? That's going to reflect it open down. And then you have y equals 1/2 to the negative x. That's going to reflect it across the y-axis. So that's going to make it, when you have a decay and you have a negative exponent, it changes the decay into that growth. So this is actually exponential growth. And this just kind of helps you. So before you do your graphing, just to kind of get an idea of what your graph should look like. And then the last one I'm missing is y equals a negative 1/2 raised to the negative x. And so what does that look like? It is going to be reflected across the x-axis, reflected across the y-axis, and okay, good. All right, so now let's do some actual graphs. Okay, so this isn't going to be a little bit tricky because I didn't have graph paper and I wanted to make nice graphs. So you guys are actually just going to kind of grid out your paper. The first equation that we're doing is y equals 2 to the x power. So go ahead, take some time and sketch out this graph. Y equals 2 to the x. And you're going to go ahead and plot these points. So you could quickly make a table of values. If you plug in 0, you get 1. If you plug in 1, you get 2. If you plug in 2, you get 4. Okay? All right. And then from here, you could plug in values. If you plug in -1, 2 to the -1 is the same thing as 1/2. So in that case, this value right there, if you were to make an XY table, when you plug in -1, you get 1/2. Okay, so go ahead and plot that. A couple of other things to know about this is the asymptote is at y equals 0, and you can draw a dashed line on your graph. Also, the domain of this, domain is all real numbers, or you can say it's -infinity to +infinity. Your range is going to be from 0 to infinity, or you can say y is greater than 0. Go ahead and add that to your graph. All right, go back to your notes page if you still have room, or just add this somewhere. This is not written in your book, but this is a general equation for an exponential. And what it is that you have some base number, and you could have a number out here, sometimes, not always. And then you have your exponent x, and then you may have a number next to this. This number right here shifts you left and right, and it is the opposite of what you think. So this number here, your h, shifts you left and right. The opposite of what you think. So if it's positive, you're going to shift left. And if it's negative, you're going to shift to the right. Almost like a vertex, but they don't call it the vertex. And this k value is going to shift you up and down. And you'll see what I mean by that in a minute. So just go ahead and write that down. Also, this k value will actually be where your asymptote is going to be. Okay, so take a minute, copy that down. Okay, now you can graph all of these again, or if you just want to do these three, but really the whole point is to just graph this last one. Okay, we already know y equals 2 to the x, right? And we know that this is our 0.01. So when I look at this, if I'm trying to do this one, we have a -1. What is that -1 going to do to your graph? Right, it's going to take it and it's going to shift it down just 1 unit. Okay, so instead of crossing at 0, 1, now it's crossing at 0, 0. The asymptote is at -1. So in this case, you can see that's our k number. So that's where your asymptote is. So your asymptote is at y equals -1. And there you go. This equation, what it does is it's going to shift it to the, oops, go back here. That is your h value. So that's shifting this point right here to which direction? If it's -3, it's going to shift it to the right 3. The other thing to note is that this doesn't have a number here. It doesn't have a k value. So that means that your asymptote is at 0. All right. Okay, so let's try to do this one. So what is this going to do to your graph? All right, well, it's going to take this point right here and it's going to shift it right 3, and it's going to shift it down 1. So it should be right there. And it is. Also, we know that the k value is -1, so our asymptote is at -1. Okay, so go ahead and graph this one. Sometimes people will graph the parent graph and then this one as well. If all else fails, you can also make a table of values. You can never get a problem wrong. If you didn't remember how to graph it, you can always make a table of values. Plug in, 1, 2, 3, whatever, some numbers, and then just see what your answers are. And that's actually how graphing calculators graph, is that they can plug in so many numbers and connect those lines. For us, we just kind of pick a couple of dots. All right. Okay. Now let's do exponential decay. Okay, so in this problem, we're doing exponential decay. And again, you can graph all of them or just graph this last equation. That's the one we really want. So we know it's exponential decay. And if we plug in 0, 0 is always a good number to plug in so that you know where it crosses your y-axis. And then that's kind of, or go back to your parent graph, so to say. So here we have this graph right here. It's exponential decay. What is this one going to do to your graph? Yeah, that's your k value. So it got shifted up 4 units. So it took this point right here and it shifted it up 4 units. So 1, 2, 3, 4. That's your k value. So that is going to be where your asymptote is. Y equals 4 is your asymptote. And you would just do a smooth graph. If you would need a couple of points to make a nice graph, but if you know your asymptote and that point right there, then it's a little bit easier. You can just kind of see it. Again, to make a good graph, you'd make a table of values to find those actual numbers. Here we have +3 in the exponent. So in the exponent, again, that's going to shift us that left-right, opposite of what we think. So in this case, it's going to take this point and shift you left 3 units. And it's not letting me click it. Okay, so it takes this point, shifts it left 3 units. Your asymptote is at 0 because there is no k value. Okay, try to graph this one. What's this going to do to your graph? Left 3, it's going to take this point right here, left 3 units, up 4, asymptote at 4. Sometimes it's easier to draw your asymptote first because you know it's at 4. So if you were, I don't know if I can draw this line. That's going to be your asymptote, and this is your point is going to be at from here, left 3 units, up 4. Now be careful. It's not -3, 4 because it started at 1. So this graph is actually going to be 1 above that. So it'll look right there because it took this point, 1, 2, 3, 1, 2, 3, 4. It's actually right there, and I don't know if it's going to let me plot it. I don't think so. Okay. All right. Okay, so you want to graph this red line. Again, your asymptote is at y equals 4. Domain would be all real numbers. Your range would be y greater than 4. Okay. If you have questions, or struggling with the graphing, Desmos.com. You don't have to download the app. You can just use it like online and just see what it does with the graph. Again, if you wanted that table of values, you can plug in numbers, and it'll tell you what those values would be. Okay. All right. So play around with that. Now we just have one more problem that we're going to try, and these are, instead of equations, they're inequalities. Well, what do you know about inequalities? Oh, inequalities have shading. So you already know what y equals 2 to the x looks like. Y equals 2 to the x looks like this. But with an inequality, we're going to have shading, and you have to pick a test point. Usually we can pick 0, 0. If you pick 0, 0, you just plug that into your equation. So y less than 2 to the x, plug in 0. So if I were to, and that's kind of hard to see. Let's see if I can do it. Okay. If I plug that in, I plug in the point 0, 0. So 0, test the point 0, 0. That's your x, that's your y. If you plug in 0 for y, 0 for x, so this is 0 right here. 0 is less than 1. Is that true or false? True. Because that's true, that means that 0, 0 is a solution. So you actually want to copy this problem down. So make that y less than 2 to the x, test point 0, 0. And I'll show you what it looks like in a minute. So we know 2 to the x looks like this. It is a dashed line. And then the only thing we have to figure out is which way do we shade? Well, we know 0, 0 is a solution, and so that's the true side, so we shade that part. If 0, 0 was false, then we would shade the other side, okay? All right, so go ahead, add that problem as well. You may need to pause and copy all this, and then we're going to do one more problem as well. This one. So this one, same thing, you're going to graph it. You're shifted from here, right 5, 1, 2, 3, 4, 5, up 1. Okay, so that's right there. Your asymptote is at y equals 1, and it's a solid line because it's equal to. Again, you'd plug in a test point. 0, 0 makes it false. So then this is a false side. You're going to shade the true side. Okay?